Hi, everyone. Uh, this is a continuation of our discussion from our last discussion on SQL injection vulnerability, where we saw why SQL injection is such a dangerous vulnerability. In this session, we're going to talk about the story of the SQL injection vulnerability. But before we do that, I want you to think about the challenge that is there with these vulnerabilities. So the biggest challenge we have sometimes with these vulnerabilities is to accurately identify these vulnerabilities without creating noise, which comes from false positives. And this is where contrast shines. Contrast is able to find the real vulnerabilities without creating all that additional noise. Okay, enough of that. But what I want to do now here is I want to go in and take you directly to that vulnerability. So what we see here is there's the main contrast dashboard. I'm not going to spend too much time on that. Let's go into our application. This was our application, WebGoat demo. If you recall, WebGoat is a purposefully vulnerable app which is there for people to come in and learn about these vulnerabilities and learn how to go. They can go about and do something about these vulnerabilities. I'm going to click on this app. As I click in, we come to the next page here, which has a lot of details. I'm not going to spend any time on this. I'm going to go directly to the vulnerability, and that vulnerability is the SQL injection vulnerability. That is actually a critical vulnerability, and I'm going to go do a deeper dive into this vulnerability. So let's click here. So once I click here, what I really see here is this is the headline for our vulnerability. SQL injection from account name parameter on WebGoat attack page. This vulnerability is critical. It was discovered on March 7th, 2021 at 10:52 p.m. Overview of this vulnerability, as you see that it was found in QA, environment QA, and it tells us that it was found in QA because the metadata that I set up as I was starting the application, I informed the agent that this is QA environment. This vulnerability was first detected on March 7th, 2021, was last detected on March 7th, 2021, and there have been 11 plus days of window of exposure. Okay, so that's good. Let's think about what happened in terms of the overall vulnerability. So if you have a web application, what you typically have is you have this internet traffic or HTTP traffic that comes to your application, and then as it comes to your application, in many cases it'll go in, which is the source where the application comes and traffic comes to your application. The data comes in, your application will do something with it. In many cases, this application will go in and then make an out call to a database, fetch some results, and provide it back. So for example, if you have a browser, you do something on a browser, you fill up the form, the data goes into your application, the input goes into your application, and as you go in, the somewhere behind the scene, a SQL statement gets crafted, and eventually you pull this information back from the database and you present it back to the user. And that's what was happening in our last session. So what we have is something like this. So let's look at what we see here. What happened? We tracked the following data from account name parameter, post, WebGoat attack screen, all of this information here, and then account name in GD, and then came a submit here. So this is the HTTP request that actually came in. It was a post request that came in, and we see that in this HTTP request, some of the details about it. Now, as a next step, what happened was this was accessed, which was accessed within the following code. So you start seeing the details here, and on line 103, this was actually accessed. So HTTP request, which was passed into the code over here on line number 103, and this ended up becoming a SQL database query as the next step. So the next step, what we see here is this HTTP request into the code becomes a SQL query where select star from user data where last name equals GD. So the thing that actually ties them all is this user input, which is something that I've typed up on the form. That user input came in and it moved from all the way here to all the way here into into this database query. The challenge with this, if you think about it, GD is not a problematic input. It's just two characters which I have provided there. It is not malicious. It is not problematic. But contrast is really smart about it. Even though the input is not malicious, we can see just based on normal input, we can see that there has been no sanitization, no validation, no cleanup of this data of the user input, which means people can come in and they can inject something which is bad into this part of the code. Now, if you are someone who's new to SQL injection, you can see some details what exactly is happening. So what's the risk? With a maliciously crafted input, an end user could change the structure of the SQL query and perform a SQL injection attack. A SQL injection is possible when developers hand build SQL statements containing user supplied data without validation or encoding. So we provide some information. If you're new to it, you can learn something from here, but we're going to give you also a link to the a massive amount of SQL injection information in a moment, and I'll share that with you. So that's good. That's a high level of our vulnerability detail. Now, if you're a developer, you may actually ask the question, this is good, I see this, but it all started with the HTTP request. I want to see the HTTP request. I want to see the headers. I want to see the body. I want to see all of that. Okay, so let's do that. So let's click on this tab here, HTTP info. Now, when you click on this tab, now here is where you can see the whole HTTP request, including the headers and all of that. You can also see the body, and that is good. So you can see that information. Now, if you're a developer or a QA person, the next thing you might say, this is good. I want to be in a position where I can reproduce this problem. So what we provide to you here is this replay request button. So you click on the replay request button, and as soon as you do that, this window will open up, and you can see over here, the method was post, and you can see this URL. This is the way you can reproduce this problem. And not only that, we give you an ability to adjust the parameters. So you can see the parameter, here's the value, there's another one, and all of that. And you can add parameters if you would like to add parameters. If you want to delete parameters, you can actually go ahead and delete the parameters. And eventually you can click on execute, and this is how you can actually reproduce the problem. So a very easy way to reproduce the problem so far. Okay, just quickly, let's recap what we have done so far. So when you came in, you could very quickly see the story of the vulnerability here from HTTP request being accessed in the code to the SQL statement and all of that to the place where we could see the HTTP, all the whole HTTP header as well as the body, and we saw how we can reproduce this request. So that is good. Now, if you're a developer, you may say, look, I want to see more details. I want to see more details, what's going on, maybe at the stack trace level. But before we do that, I want to give you actually another view of this vulnerability, another view of the story of this vulnerability, which I think you might find fascinating. So let's click on the details tab here. When I click on the details tab here, what you see here is this over here, we had the HTTP parameter retrieved. So when it was retrieved, you can see some details, wrapper.get parameter value, account name, and you can start seeing already this is starting to build up, right? And then there were two string operations that happened. So the two string operations that happened were data flowed from parameter to object, and then data flowed from object to return value. And you can see the details as it's actually happening on over here. And then finally, the the biggest challenge of where we see that what really was problematic was this untrusted data was used in the SQL query. Now, untrusted data, what it really means is all the user input that comes in, we can consider this is all untrusted unless we have some controls in place by which we clean that input, we validate that input, we do something with it, but none of that exists along this path. So we said this untrusted data was used in the SQL query, and you can see some details here. Now, as I mentioned just a minute before, as a developer, you might want to see the stack trace, and you can see that. So let's click on this drop down, and you'll start seeing a little bit more detail around what is going on. So let's click this. So when I click here, you start seeing untrusted data used in SQL query, class method. You will see some details here. You will see the object. You will see the return value. You will see parameters and all of that. So you start seeing some of these details. Now, if most applications today, they are a combination of a custom code and the library code. If you want to see the stack trace, the complete stack trace, just click on see more, and you will very quickly start seeing the stack trace of this whole transaction. Now, if you want to be very specific and you want to see just stack trace for your code, you can do that. You click on custom code and we'll just show you that. If you want to see just the library code, you can do that. And now we show you just the library code stack trace, or you can come back and you can give the all code and you will see the whole picture. So this is good. So you saw so far what we have covered so far. We look at that at a high level, the story of the vulnerability. We saw the HTTP information, how you can reproduce the problem. You also saw the details. But now comes the most interesting piece. If you're a developer, You would say, okay, I understand, I get all of that, but what do I do about it? How can I go ahead and fix this problem? So you click in here with how to fix, and we'll start giving you some additional information. And this information is specific to your language and the vulnerability type. So let's review for this language, and let's review for this specific vulnerability type, which is SQL injection. So let's see what we provide here. There's the most effective method of stopping SQL injection attack is to only use an ORM like Hibernate that safely handles database interactions. If you must execute queries manually, use callable statements for stored procedures and prepared statements for normal queries, so on and so forth. Now, we don't stop here. What we give you also is information. Here's an example of an unsafe query, so you can see that. And here is an example of the same query made safe with prepared statement. So that's good. So it gives you some idea about how you can go about it, but there is more to it, right? So we recognize in some cases it is a little bit difficult. So we also give you an option said, okay, if you don't want to use that, maybe you can use eSAPI library because it offers some additional functionality here. And then we talk about, here's an example of encoding a dynamically built statement for an Oracle database using untrusted data. So that is an additional way, and you can look at what makes most sense for you. It gives you some ideas to think about, and then you can say what makes most sense for you, and you can make a choice or a decision based on what is most relevant for you. Now, as I mentioned a few minutes ago, that we also give you links to the place where you can go in and learn a lot more about SQL injection. So if you are interested about this, you can actually reference directly from here the OWASP cheat sheet, which I find is fascinating. A lot of really great information. So you can do a really, really deep dive into it. Um, and you can also watch a video on this topic with Secure Code Warrior 2. So there's a lot of information for you to be able to learn. There is no expectation that a person who is coming in has a lot of background. We don't expect the people to be able to come in and be in a position that where they bring in a malicious payload and they're able to hack the application. None of that. What you do is you come in, you just use the application as you would. If you don't know what SQL injection is, you will come in here. You can go to the Secure Code Warrior site. You can learn something here. You can go to the OWASP cheat sheet. You can learn something here. And we have provided some information to you as well. And if you want to be very efficient, you can use all the contrast information and move very quickly from learning about the vulnerability to actually going ahead and fixing the vulnerability. Now, there is some additional tabs here, which I don't think are so very relevant about this discussion for this lesson here. Now, I want to leave you just with this thought. The power of contrast, one of the key powers, one of the key things contrast has is you do not need to provide the malicious input or payload to exploit the vulnerabilities. All you have to do is use your app as you normally would, and all of these vulnerabilities will start appearing. I hope you have enjoyed this lesson. I wish you well. Thank you very much.